Okay, so the way I've solved this is I've taken the data that was provided and split that into the training data and validation data. I taken 80% of the observation as training data, 10% as validation, and 10% as the test data. And I try to use both Excel and as well as the Google Cloud Auto ML. And I have uh, so I started off using the regression model uh, in the Excel. So I tried two methods here. I used I used all the features in the model, namely the ATP, AP, and RH, humidity, temperature, pressure, and vacuum, as the uh, input variables, and P as the output variable, P being the hourly electrical energy output, which is what we want to calculate as the output variable. And I use the regression uh, here to capture that input, Y being the output variable. Use a 95% confidence level and then calculate the rest years. So as you can see that my model, the R square, which basically says what's the attribution of the input variable to the output variable, is 92%, which is pretty strong, which basically says that all these factors have a strong contribution towards the results. Um, and I also use that to calculate the predicted values of my output variables here. When I used a smaller number of factors, so when I tried to do the same, but with the first three factors, um, so I'm basically using column A, B, and C, the A, T, B, and AP as the factors in my model. Um, then I see that my R square has gone down a little bit to 91%, which basically means that the fourth factor is has less attribution to the outcome. And if I do the same thing with uh, only the first two columns as the factors, meaning the temperature and the vacuum as the factors, then I see that model hasn't changed much either. And if I just use the first factor in my model, then I see 89% R squared, which means that the huge the AT factor, the temperature plays a huge role in the output of the output variable, so that the contribution of AT factor is high. Irrespective, so I have set up my model such that I calculate the predicted variables based on the formula using the intercepts. Um, and I can see that when I use that, then um, I get a pretty good prediction of what the output value is. I try to do the same in Google as well, in using the Google Cloud as well. So here I've used two different models. I used two different optimization to calculate my use in my regression model. And I should mention that I'm using regression model here because it's essentially a regression problem. Um, so I used RMSE model, which is basically root mean square error, versus the MAE model, which is the average uh, uh, absolute errors, the mean absolute error model. Um, I can see that the R square on the root mean square model is 95%, which basically has a higher fit, a higher attribution to the outcome versus the 88% on the other model. Seems like this model has a pretty good fit. And when I do an evaluation of the model, I can see the feature importance of the temperature being the highest contribution to the model. So, so I'm using that to calculate my responses. So I can predict the values of my